Something is wrong with these pictures. These strange artifacts and distortions, they aren't just our eyes playing tricks on us. Gravity is actually bending the light in these photos. Let me explain. According to Albert Einstein, massive objects like stars or planets can actually warp the fabric of space-time, kind of like this ball on a curved sheet. And this is actually what we feel as gravity. That's gravity. Now light, a form of electromagnetic radiation, has zero mass, and because of this, it always takes the quickest path relative to time. Now in a flat environment, this is a straight line, like this river. But the landscape this river flows through is not always flat, so the flow of the water is actually forced to bend. Now when light encounters a curved gravitational field or warping in space-time, the light naturally follows this curve, just like the water in the creek, altering its trajectory like a really out-of-focus lens. This bending of light by dimples in space-time is called gravitational lensing. The strong form of gravitational lensing is what gives us these strange images from before, like the famous Einstein ring and cross images, where the warping is super dramatic. The distortion we perceive is actually an entire separate galaxy behind the lens galaxy. In this case, light from a distant quasar takes 4 separate paths through space, warping around the lens galaxy. Astronomers can even measure differences in these light fluctuations to calculate the distance the light has traveled, which allows us to measure the Hubble's constant, or the rate of expansion in the universe. But what's even more crazy is that light can be warped by thousands of these gravitational lenses as the light navigates around star systems and galaxies on its way to Earth. This is called weak lensing, and by doing some calculations, astronomers can locate invisible clusters of dark matter that silently participate in this distortion. Even smaller objects like exoplanets and stars can cause microlensing. Tiny differences in brightness and magnification can allow us to detect exoplanets that could potentially harbor life. By decoding these gravitational illusions, we can further understand the inner workings of our cosmos.